Hello, everyone, and welcome to Online Lecture 7, Types of Research, Day 1. Okay, so let's jump right in and start talking about some different types of research. So, one way of categorizing research approaches is between experimental and descriptive. So, experimental attempts to identify cause and effect relationships through psychological experiments. So the key here is cause and effect. Okay. Now, it may not always be successful in identifying cause and effect, but that's its goal. Now, a descriptive study focuses on describing phenomena, events, or situations. Okay. So we're going to start off in experimental land for today. And But first, before we even jump into the psychological experiment and start talking some details about that, I want to go over some terms that apply to both experimental and descriptive research. Okay. So for example, you can have categorical or quantitative variables. Okay. Categorical variables are categories with no natural order. Things like gender, religion, college major, method of therapy, eye color, etc. You can also have quantitative variables. These are numbers with a natural order. Things like reaction time, height, age, anxiety level, order of finishing a race. They're all quantitative variables. Okay. Now, in order to really understand these kinds of variables, we're going to break them down into 4 categories. Now, we're going to leave categorical alone. We're just going to change the name, but we're going to leave that one alone. It's quantitative that we are now going to break down into 3 other categories. So one way to think about these different categories is to use the mnemonic, no oil in rivers. Excuse me. And no, the N stands for nominal or categorical. The O stands for ordinal or rank order. The I stands for interval or equal interval. And the R stands for ratio. And you will notice that the first one, nominal, is categorical, whereas the remainder are all quantitative. So we've kind of already talked about nominal or categorical variables. These are variables in which the values are categories with no natural order. Again, things like gender, ethnicity, major in college, eye color, etc. Okay. Ordinal or rank order is when you have a numeric variable in which the values correspond to the relative position of things being measured. So for example, finishing order in a race. Socioeconomic status, if you classify it as low, medium, high. Birth order. Okay, those are all ordinal variables. Now, interval or equal interval is a numeric variable in which differences between the values correspond to differences in the underlying thing being measured. That's more of our typical rating variables that we consider. It's also temperature in Fahrenheit or Celsius. Okay. So if you ask someone to rate their stress level on a scale from 1 to 100, that would be an interval variable. Okay. Now, the basic difference between interval and ratio is the 0. In interval, 0 does not mean the absence of the thing being measured. And the best example I can give you is temperature. So if you're measuring temperature in Fahrenheit or Celsius, then 0 does not mean the absence of temperature. If we're talking about 0 degrees Fahrenheit, it's very cold, but we don't have the absence of temperature. If you were asking someone to rate their mood from 1 to 10, let's say, or even from 0 to 10, with 0 being a very poor mood and 10 being a really great mood. Again, 0 does not mean the absence of mood. It's not an absolute. Now, some people will argue that actually rating scales should be ordinal and not even interval. Because can we really argue that on a rating scale from 0 to 10, that the distance between 1 and 2 is the same as the distance between 2 and 3? Now, people take different opposing positions on this. For the purposes of this class, we'll consider rating scales an interval measure. But you certainly can make the argument for them being ordinal. Okay. All right, so now that leaves ratio, which is the same exact as interval, except now 0 means the absence of the thing being measured. Things like weight, height, reaction time, length, and even for those of you physicists out there, temperature on a Kelvin scale, because the Kelvin scale actually has an absolute 0, where 0 is theoretically the absence of all temperature. But typically, like I said, we typically talk about temperature in Fahrenheit or Celsius, right? So we're typically interval. I just throw that out there. Okay. So that's your nominal, ordinal, interval, and ratio. Let's move on to independent versus dependent variables. Okay, this is probably just like perhaps the last slide, something you may have talked about in slide 245 in a statistics class. The independent variable is presumed to cause or be associated with changes in another variable. It's the variable that's manipulated or observed by the researcher. So it could be if you split a group in half and half the group got therapy by random assignment and the other half got no therapy by random assignment, that could be one split that would be made. If you were looking at a younger group versus an older group, that would be another independent variable. Now, the difference between those two, I will share, is that with the therapy versus no therapy, I can manipulate that variable. I can assign people to therapy groups. Whereas with the age variable, younger versus older, I can't assign people to be different ages. For example, if I walked up to you and said, oh, for this study, you're going to be 52 years old, you'd probably look at me like I'm crazy, right? Because unless you happen to be 52 years old, of course you can't do that, right? People come as they are, whatever age they are. I can't assign it. Okay. And that's going to be an important issue we come back to. Dependent variable, the presumed effect or outcome of the study. It's the variable that's measured. It's the variable that's influenced by or associated with the IV, such as a mood rating, such as time to complete a task. So here's the way I think it's easiest to figure out IV versus DV if this is a struggle for you. Start with the DV. Start with the dependent variable, okay? And then decide which one is my outcome. Which one am I measuring? Which is my outcome? That's your DV. Okay. And particularly focus on outcome, because there could be a circumstance where you measure your IV as well, but typically it's the DV. So look for your outcome, call it the DV, then look for your IV. Then look for the one that you're manipulating or observing. Okay. Now let's talk a little bit about extraneous variables. This is a variable that competes with the IV in explaining the DV. They're sometimes called third variables or confounding variables. So let's say I wanted to show, I wanted to study finger dexterity. Okay. So I decide to compare a group of younger folks who are in their, let's say 18 to 25. And then I'm going to have a group of older folks who are 45 to 60. Okay. Now, I give them both a typewriter, right? Put in a piece of paper and see how fast they can type a sentence. You might be having an objection to this study, right? It might not surprise you if the older group actually did better, even though you might believe that, you know, younger people in generally can type a little, can actually move their fingers a little quicker, have better finger dexterity, okay? So what's your objection? It's that people who are older also happen to be more familiar with typewriters. It was technology in their day, not usually used in the current day. So the younger generation might struggle a little bit with figuring out how to do the different things, right? So that's an extraneous variable that I introduced. Okay, inadvertently, but I did introduce it, right? The actual knowledge of how to use a typewriter. So that probably wasn't really the best way to test this. Okay. Let's talk about mediating and moderating variables now. A mediating variable occurs between two other variables in a causal chain. It might also be called an intervening variable. Again, that's an intervening variable. Okay. So let's say I'm interested as to whether anxiety affects memory. Does anxiety affect memory? Well, there might be an important mediating or intervening variable in there. You see, maybe it's not just that anxiety affects memory, but anxiety affects distraction, and distraction affects memory. Distraction, that one in the middle, is your mediating or intervening variable. So anxiety to distraction, distraction to memory. Now, a moderating variable, on the other hand, is when you qualify a causal relationship as dependent on another variable. Now, let's say that the impact of anxiety on memory depends on the level of fatigue. Fatigue is a moderating variable. Let me explain that. So in other words, we're going to take one group of people that's fatigued and one group of people that's not fatigued. Then we're going to look at the impact of anxiety on memory. And maybe we'll see a different relationship. Maybe for someone who is not fatigued, anxiety doesn't have much of an impact on memory. But if you add fatigue into the equation there, if a person is fatigued, then anxiety does have an important impact on memory. So that fatigue becomes a moderating variable, right? And when you have a moderating variable, you're often thinking of one group that's high, one group that's low on a characteristic, and how those have different, how that affects the relationship. Okay. Causation. So causation is a very important area, and it's one that I already shared with you. We tried to get at with the psychological experiment. So let's say what the IV and DV actually are. So the IV is a condition in which one event, the IV, right? Condition in which one event generates another event, the effect, the DV. Okay, so causation, a condition in which one event, the cause, the IV, generates another event, the effect, the outcome, the DV. Okay, so let's take an example here. Let's say that you want to see if garlic decreases blood pressure. Okay, so you give one group of people garlic pill every day that they must take, and at the end of 6 months you measure their blood pressure. Another group, you say don't have any garlic and any food anyhow, anyway, for 6 months, and then you take their blood pressure. Maybe you even take their beginning blood pressure as well so you can see the change. Okay. Now, if I assign those groups at random, I might be well on my way to looking at causation. If I just let people choose whether or not they wish to take the garlic pill or not, whether or not they wish to go garlic or garlic free, then there's no way I can talk about causation. And the reason for that is that I have introduced a very important bias into my study, right? I've introduced a extraneous or confounding variable in this case, where people's choice maybe relates to blood pressure. Maybe those who chose to take the garlic pill are also motivated in other ways to lower their blood pressure and are doing other things. Okay. So that's a little bit about causation. Now let's talk a little bit more specifically about the criteria for identifying a causal relationship. First, and this is the one I just showed you, the IV is manipulated by the researcher. I choose who's in my garlic and no garlic groups, and I randomly assign that. Next, the cause, the IV, must be related to the effect, the DV. So as the garlic group takes garlic, we should see decreasing blood pressure. As the non-garlic group does not take garlic, we should not see the decreasing blood pressure. So we're looking for a relationship. Now, the changes in the independent variable must precede the changes in the dependent variable. That's called the temporal order condition. In other words, we want to make sure that the IV happens before the DV. Right? So we want to see that the independent variable changes happen before the dependent variable changes. Okay. And finally, and this is the toughest one to do, no other plausible explanation must exist for the effect. That's challenging. Okay, so let's go back to our garlic example. We talked about how the IV was manipulated, right? Because I randomly chose half my people to be in the garlic group, half my people to be in the non-garlic group. Let's say at the end of my study, statistical analyses showed me that my garlic group had a significant decrease in blood pressure compared to my non-garlic group. Great, I've got relationship condition, I got part 2. I can see from the beginning of my study, when I took everyone's blood pressure right at the beginning before they were assigned to groups, that really both groups were equivalent at the beginning. So any change that happened after I introduced the garlic. And as I said, here's the toughie, no other plausible explanation must exist for the effect. Who knows? Right? Maybe people who were assigned to take the garlic got all inspired, decided I'm going to exercise more, I'm going to eat better, I'm going to do all these other things to help out my blood pressure. And maybe people in the non-garlic group said, nah, I'm not going to bother. Why should I? I'm not even in the garlic group. We don't know. Now, how can we help that even more? Well, maybe we could not tell people which group they're in and give everyone a pill to take every day. Some are garlic, some are placebo, or some are just, they don't have any garlic in them. They have nothing. Okay, so that's the challenge. Okay. So now let's get into the psychological experiment proper now that we have some terms defined. So we have objective observation. We want to have impartiality and freedom from bias on the part of the investigator. So we're going to set up our experiment to help ourselves, because we're all biased in some way or other. As hard as we try to be completely impartial and completely free from bias, the minute we set up a hypothesis, we want a study to go a certain way. Right? Okay. So Zimny, and this is a very old reference back from 1961, has 3 rules for minimizing recording and observation errors. 3 rules that can help our objective observation. First, accept the possibility that mistakes can occur. Second, attempt to identify where the mistakes are most likely to occur. And 3, take the necessary steps to avoid the errors. Now, I know that sounds kind of the obvious, but it can be a very helpful thing to think about as you're setting up your study. For example, where are the most likely to have an error? Well, maybe if I leave an open blank versus a multiple choice, it can produce, more likely to produce some kind of something I can't code or observe or something like that. So I know, for example, that one time someone had a question of, how many friends do you have? And left a blank, right? This was part of a survey. And one person wrote in, enough. Well, what are we supposed to do with that answer? How are we going to code that? How are we going to work with that? So maybe we could have chosen to do something else with that kind of answer. Who knows? Okay. So objective observation of phenomenon that are made to occur, any publicly observable behavior, in a strictly controlled situation in which one or more factors are varied and others are kept constant. So in an ideal world, the only variability in the experiment is your independent variable. No other extraneous variables are allowed to threaten the study. So hopefully in my garlic study, the only thing that's moving around, the only moving part, is whether you're in the garlic group or non-garlic group. That's the only difference between the groups. In all other respects, we hope the groups are exactly the same. All right, and that's the next point. Groups must be the same except for the levels of the IV. And random assignment helps to construct equivalent groups. So random assignment becomes very, very important. Okay. So before we get into advantages, let me just share with you a quick example of a psychological experiment. So once again, let's consider a convenient sample of 100 people experiencing generalized anxiety. But we're going to take that convenient sample of 100 people experiencing generalized anxiety, and 50 are going to be randomly assigned to the treatment group, which is a new drug in pill form for anxiety, or the control group who takes a placebo pill. Okay, placebo pill is basically a pill that has no effect. Okay, so it only has inert ingredients. Okay, and for our DV, we're going to measure anxiety levels. Okay, so once again, we've got convenient sample of 100 people, split them randomly into 2 groups. One group gets the treatment pill, the other group gets the control pill, the placebo pill. What are the results? The participants in the treatment group show lower anxiety after receiving the new drug compared to those who receive the placebo pill. What would you conclude? Is the drug effective? So think about that. Would you conclude that the drug is effective? Probably, right? We made objective observations, we made key phenomena occur, and we varied the IV and held other variables constant as much as possible through random assignment and testing the groups the same. Now, isn't that interesting that we are able to do that even though we had a convenient sample to start with? And that is true. And that's the power of random assignment and of treating your groups the same. Now, if you have the same example without random assignment, again, same IV, new drug for anxiety, same DV, measuring anxiety levels, but you're going to let those participants self-choose which group they want to be in. What are you going to get? Who's going to choose to be in your treatment group? Right? Those who want treatment, those who are willing to take a medication are more likely to be in the treatment group. Those who fear medication are more likely to be in the control group. And so we've created a confounding variable. We have created a confounding variable, which is an extraneous variable that's allowed to vary along with the levels of the IV. The motivation to take medication has been allowed to vary along with drug versus placebo. Now, we cannot make the same conclusion. We cannot say the treatment's effective even if we have the same results because of the confound. Okay. So now we can talk a little bit about the advantages of the experimental approach, because there are some advantages. First of all, we have causal inference. Experimental approach is the best method for inferring causation. What are the consequences of manipulating an IV? And of course, the ability to manipulate variables. So it's all about causation. It's all about ability to manipulate the IV. Okay? So if you're trying to show causality, the experimental approach is for you. Control. Extraneous variables are controlled by holding them constant using random assignment, matching, which is something we'll talk a little bit about later on. But I'll give you a quick example that if you have a 32-year-old white female in one group, then you would try to have a 32-year-old female white in your other group. That's the idea of matching, trying to control on as many factors as possible. There's a little more to it, but that's the basic idea. Okay? All right. How about disadvantages of the experimental approach? So for one, it does not test the effects of non-manipulated variables. So there are many potential independent variables that cannot be manipulated. People's ages, gender, weather, involvement in a natural disaster, or being impacted by a natural disaster. Now, that doesn't mean that those variables aren't important or worthy of study. Of course they are. But the experimental approach might not be the best way to get at them. The next disadvantage is artificiality. Potential problems in generalizing findings from the laboratory setting to the real world. Now, this is lovely that we've set up this beautiful study that works just perfectly in the lab. But what happens when we try to, bring it to a real world setting? Maybe people aren't so compliant with taking their garlic pill. Right? Maybe people who take the garlic pill say, oh, I'm covered. I can, not worry about what I eat. I cannot worry about exercising because I'm covered by this garlic pill. Don't know. Inadequate method of scientific inquiry. Yes, by itself, it is inadequate. It is a very good method of scientific inquiry, but it's not the only one. Okay, so we wouldn't say that's it. Okay. Now, when we're talking about experimental research settings, one place we could have an experiment is out in the field. We talked a little bit about laboratory, but let's talk about field experiments. An experimental research study that's conducted in a real-life setting. Now, the advantage of this is that it may be easier to generalize the findings, right? We've got it in real life. This is great. The disadvantage is less control of the extraneous variables, right? If you're putting it in real life, there's certain things you're not going to be able to control. So I want to share an example with you of a study, but in order to do so, let me just define the term confederate, which is someone working with the experimenter to set up the experimental situation, and it's not known to the participants. So it's someone who's in on it, working along with the researcher. Okay. So there was a study done by Reagan and Yamas in 2002. They wanted to find out if a female shopper's appearance influenced the amount of time it took for an employee of a store to approach and acknowledge her. Okay. So what's the IV here? Well, it's how this female confederate is dressed. She either wore formal work clothes with a lot of grooming and makeup and those sort of things, or informal sports clothes with less grooming. Okay. The confederate entered randomly selected women's stores between the hours of 3 p.m. and 4 p.m. on 2 consecutive Thursdays. Notice how they're trying to control as much as possible in this real world setting, right? They're making it on Thursdays, they're making it at a particular time, they're doing the best they can. The dependent variable is the time it took for an employee to approach and speak to the confederate. So upon entering the store, the female confederate activated a stopwatch and proceeded down the first open aisle. Then she stopped the stopwatch when an employee approached and spoke to her. So any guesses as to what happened in this study? I'll show you. Here you go. And this isn't a statistical analysis, this is just a bar chart here, but you can see that when the female confederate wore formal clothing, it looks like she was approached quite a bit faster than when she was wearing informal clothing. So that's a typical example of an experiment happening in the field. Hopefully more generalizable, but also more problems, right? We can't control who the employee is in the store on these 2 consecutive Thursdays. It could be that on the first Thursday when she was dressed formally, that you have a much more attentive employee than on the second Thursday when she dressed more informally. Can't control that. Okay. Not as well as you could in a laboratory experiment. Laboratory experiments are conducted in a controlled laboratory setting where you have more control over extraneous variables and less generalization related to artificiality. Okay, so here's a big point that I want to get across to you. There's a trade-off between field and laboratory experiments. Field, less control. Field has less control, but it also has less artificiality. Laboratory has more control, but less generalization due to artificiality. Okay, all right, that's the trade-off. Now, another place where, especially these days, experimental research occurs is online, right? What's the advantage? Well, you have access to diverse populations. You can bring the experiment to the participant. You have a large sample and thus greater power. And you have direct assessment of motivational confounding and cost savings. So it's nice. You can access a lot more people this way. It can be really, really helpful. But what are the disadvantages? Lack of control is the biggest thing. First of all, people are self-selecting into your study by choosing to participate. It's a little bit different than walking up to someone and saying, hey, would you take 5 minutes and be part of my study, than doing it online. People are more likely to agree in person, right? You could have people participate in your study multiple times. And it's easier for participants, for the same reason, to drop out. Again, if someone's in person, it's less likely they're going to be like, I'm bored. put down the paper and walk out on you than it is for them to do that online. So there's definitely some advantages and disadvantages here. Okay. I actually want to go back for just a second and give you a nice example of a laboratory experiment. This is by Kassin and Kiekel in 1996. They wanted to experimentally demonstrate that vulnerable individuals under the right circumstances would confess to an act they did not commit and even have memory of committing the act. So the IV here is the vulnerability of the participant. Okay, so how are you going to manipulate vulnerability? Well, they had a clever way of doing it. It was created by having the participant complete a task at either moderate speed or fast speed. So the idea being, if you're just completing your task at moderate speed, you're in the control group, you're not really vulnerable. But if you're asked to complete it super fast, you're in the vulnerable group because maybe you're more likely to believe you made an error. We also had the presence of a person who was either falsely incriminating the participant of making the error or not. The DV was confession to making a mistake. So what was interesting in the results is that individuals were more likely to confess to making a mistake they had not made in the vulnerable condition when a confederate or witness said that the research participant had made the error. In fact, those vulnerable individuals were more likely to internalize the false confession and tell others they had committed the error. Now, of course, this is something we're going to talk about a little bit later on, which is debriefing. After this kind of study, you certainly want to let your participants know what had happened during the study, that they were false incriminated, that they did not make an error, those sort of things. But it's an interesting setup there. Okay, and some would even argue, well, is that okay to even do? To let people think that they had made an error when they'd not. And it might depend. If it was a simple puzzle task, it might not be a big deal. So that would have to be looked at a little bit more. Okay, so that's your example of a laboratory experiment. Notice all the tight controls on it. Notice how people are coming into a lab setting, right? And there's not a lot of choices for them to make. Everything is pretty much controlled. Okay, all right. We talked about internet experiments, so that's all I have for you in this lecture. Have a great rest of your day, stay safe, and I'll talk to you next time.